This is a presentation run somewhere else, so I'm just going to try to fast forward through this. Originally, it was a write a monad in JavaScript and extend the monad in the Q&A. Let's see how much we can do. Write a monad in JavaScript is already super useful and will deliver a lot of value. Before we begin, I just want to test something, because during this coding exercise, I will ask you to send me messages. If you don't know something as we code, you can send me a private message. So I just want to see that the private messaging works. So if you want to just use this time to explore the Hopin interface and just send me a private message and tell me what you might expect from this workshop, or just say hello and what might be puzzling you about monads. How do you send a private message? Yeah, it took me actually. Actually, oh yeah, okay, I got it. So you need to click on my. You need to click. Yeah, yeah. So you have a. When you click on my name, you'll see start typing at the bottom, and you can immediately start typing. So when you click on my name, you'll then immediately see on the bottom start typing the same way you would see in a session chat, and you can just send messages there. So there's an invite to video call button, but then on the bottom it says start typing, the same it would with. Okay, I have some people coming in. Hopefully, the rest of you, if you need it, you'll discover that as you go. You don't need that chat functionality, but it might be helpful during the workshop. Okay, so like quick context, we'll be using JS Fiddle. I will explain about JS Fiddle a little later when I shared the link. We will use a sort of test-driven development inspired flow. So we'll start with a test. I'll let you implement a code that makes that test pass, make that test work. Steps are really tiny. You should take you 1 minute, maximum 3 minutes to pass each test. And after each step, I will share an updated solution. Again, I share a test with you first. That will be a link that I sent on chat. You'll get a few minutes to write the implementation, which reminds me, sorry, I need to get my phone. I will tell you when there's half the time left. If you're struggling, just send me a private message and I'll try to give you some tips. And then I will just show you the implementation. If you're struggling, that's fine. A part of the process is struggling. For some people, this might be a little more difficult than for the others who might be familiar with these concepts. But let's just try to have as much fun as we can. And then rinse and repeat. There's going to be a few tests, and then we'll have finished in around 15 minutes. Okay, so step 1, we'll implement the simplest monad. Let me share the link with you. So I'll be sharing a link in the chat now. And then I'll be clicking again. Oh yeah, question from Anne Bush, what's monad? Hopefully in 15 minutes, you'll know, but very quickly it's a type of a design pattern. So it's a concept from functional programming that's gaining more popularity in JavaScript. Is a sort of a pattern. So it's sort of like a concept that captures something that can be reused over and over and basically help your coding. But if you just wait 15 minutes, we'll do a few. You should sort of see in practice, learn in practice by example in the process. So I'm trying to take an approach to show what it is, rather than explain, because I think it's easier. Okay, so I shared a JSVideo link, and I will go to this link myself, so you will also see it on the screen. So I'll basically all of you who want to participate, and I certainly invite everybody to participate in this coding fun journey. I just click on the link, just see the link that I shared in the chat, and then we'll start coding. Okay, hopefully most of you are there. Responding to chats. Okay, so so step 0 is to step 0 is to we're gonna have a box. So we forget about monads for a second. We're just going to work with a box. So we have a box function, and that box function will take a number 3 and return an object, and that object needs to have a property value, and that will be equal to 3. So hopefully simple enough. I'll give you 2-3 minutes, maybe let's start with 3 minutes, to implement a function that will make this test pass. So you can start writing where it says write your implementation below, and then on the right-hand side, you will see a step 0. Currently it's red, and that will go green once your function is implemented correctly. So you would basically start writing here, or you can say function box and start implementing it in your own JSVideo. So let's do it. Whatever happens, happens, and you'll have 3 minutes to implement that. But yeah, question from Darren: do we write box code in the same file as the test? Yes, just write where it says write your implementation below. You can literally start on the next line. So it's going to be a large single file where you can write everything. Oh, sorry, I totally forgot to to run this. There's a run button in the top left corner of the window. So if you click run, it will actually re-evaluate, execute your code. And you have 1 more minute. The time is up. I will now implement this on my screen. So the way I would implement it is, and there's many ways to implement it. And if you haven't managed, that was just warm up, so it's fine. I would use an arrow syntax in JavaScript, and I would say const box, take a value in, and return an object that has a single property, and that's a value This is actually, I could write like this, but in JavaScript you can also just write this, and it's the same thing. Here you go. It's passing. And now off to the next step. If you can just give me a second, I need to look at my complete solution to reference. Okay, so as a next step, one, we'll implement another function for our box, and that function we'll call funky, and the funky will accept a box with value 3 and a function. So it's also called a fancy name, higher order function. Basically means a function that accepts a function. So that increments the value by 1. And that should be equal to box with number 4. So we have a function that takes a number and increments that number by 1. And we are using this function and our box. And you need to implement a function funky that will then give us a box with number incremented by 1. And you'll have 4 minutes to explore this. And I'll just share with a link. So if you want to start from here rather than from where you left off, if you didn't manage to get the previous one, there you go. And you have 4 minutes to get that test going. And feel free to send me a chat if you get stuck or you have questions or there's something that I'm just not explaining very well and you need clarification. Just 2 more minutes. Okay, time's up. Now let me show the solution. Another step of exercise for you. So function funky takes a box and a function. And then what happens is we can extract the value from existing box. So we sort of reach to the box. It's sort of like we're repackaging the box in a way. My mom used to collect this wrapping paper, and then you would like very carefully take the wrapping paper from the box, and then it would repackage the new gift with this wrapping paper. So it's sort of a similar exercise. So we take the value from this box, and then we create a new value by applying the function to a previous value that was in the box, and then we package it into a new box. So now box has a new value. So we sort of reach to the box, repackage the value, and package the new box. And that hopefully will work. Yes. It's always a little stress when you write something in a live coding exercise. Okay, so hopefully that's maybe it's similar for some of you who managed to implement this. Now, in monadic world, now there's a lot of fancy words when you go to monads in functional programming. So this repackaging of a value by using a function is called a map. So this function is called a map. And if you see a similarity with arrays or lists, because they call the function is called also a map for arrays and lists, that's because this is the same function really, but applied to different type of structure. So the method map in many languages actually comes from this functional programming concept. And when a box, another fancy word that you might see in Stack Overflow is if your data structure supports this map function, we call it the functor. So two fancy concepts here: a function map and a functor. Okay, so we learned what a functor is. It's a super fancy, weird name, but it's actually relatively simple once you sort of wrap your brains around it. Okay, cool. So let's get to the second step. The second step is going to be a bit more challenging. So bear with me. I'm going to give you step 2. We'll implement another function for our box. We're going to make our box more powerful. So we call it funkier. Our funkier function will take the box with a value and, lo and behold, a function, but a function wrapped in a box. So we take two boxes, and we're going to have to do some more elaborate repackaging. It's actually not that difficult once you kind of figure out the trick here. So be patient with yourself when you're trying to implement this one. And the link to this next step is here. Oh, sorry, it's a question from Darren. So the map is the functor. So this is slightly tricky. Hopefully I'll be able to explain it. Because we're doing it in a functional style, so we don't have classes, but instead functions are outside. So if we had a class, we would say class box has a function called map. And then box would sort of implement interface functor if you're familiar with classes. Now, because I'm doing it in a functional style where I don't have a class, my function is outside of the class, and because it's outside of it, it's not the map function that's a functor, but we say that box has the capability of the functors. Sorry, I hope that's making sense. Because we implemented that map. So we sort of made it's very subtle difference. If I'm not explaining it well, it's not super important, but we sort of enabled map to be a functor. If you call map a functor, it's like it's close enough. It's subtly different. But if that subtlety, I'm not explaining it well. That's not really a huge deal. I hope that makes more sense. If it doesn't, that's okay as well. It's a subtle difference. Is that okay, Darren? That's a really good question, by the way. Kind of makes sense. Yeah, if it doesn't fully, that's fine. It's like very subtle. So you can yeah, it's not super important at this stage. So okay, next step. Yes, sorry, putting the link. And you have 3 minutes for this one. We're halfway through. You can 1.5 more. You have 1.5 more minutes. Time's up. Let me show you my proposed solution. Again, it can vary for you. So how I would approach it is, I would say function funkier takes a box and function with a box, and then what happens is I first reach to my first box and take a value out of that box. And then I extract function from the box. So now I extracted things from both boxes. I'm I'm slightly struggling myself as well. And then I repackage it by applying function to actually, so I can have a new value, and that new value is a function applied to a previous value, and then I can put it in a box. What did I break? Oh, return. Ah, that was close. Okay, so that's a funker function. Now that funker has a funker name. So one name that I think most commonly you'll find is called AP. And AP stands for applicative. So again, if you have a box, so if you have a data structure that has you implemented a map and then you implemented AP, then that will be called applicative. So a functor is if something has a map. An applicative is if you have both map and an AP. So once you have both these two methods once we have these two methods implemented, our box became an applicative. Now, these all look really fancy, but as you can see, they're actually quite simple ways of kind of shuffling those boxes around. And you will see people using these terms a lot, and they can be really intimidating. And certainly, it have been really intimidating for me. But there's actually relatively simple concepts behind. Cool. Okay. So, what did I do? So we're almost there. We have last step to implement a monad, full-blown monad, and that's really cool. You'll be able to tell all your friends, all your nerdy friends, that you can implement your own monad now. And step 3. Yes, Darren. So Darren asked a very good question. The box and the map function together make the box functor. Yes, that's actually much way better of saying it than I did. The box and the map function make a box a functor. The box and a map and an AP function make the box applicative. Thank you. I will totally steal that explanation now. On to step 3. Now, step 3 looks very complicated, but it's actually really easy. So again, as you're implementing it, just be patient with yourself. It takes a box, and again, you might already guess, the second argument will be a function, and that function will take an argument and instead return a box with our favorite increment function applied to that value. And that looks really fancy, but I swear to you, it's actually really, really simple. Okay, and I'll share the link with you now. So next step. And again, if you have any questions, feel free to chat to me. And I'm going to give 2 minutes for this because I think it should be easy for you. Again, if you don't manage to get this, that's okay. It's the journey that matters. You have one more minute. Okay, so time's up. I will now share my solution with you. Okay, so the way I would go about this is I would have my function funkiest, and that takes a box and a function that returns a box. So as usual, we take the value from our previous box because we need to package it. And new value, it's actually quite simple. We just take the function that returns box and apply and give it previous value. And then, oh, sorry, it's actually a new box. And then we have a new box. That's actually quite quick. And will that work? Yes, it works. Awesome. And now we have, you guessed it, a monad. I don't know why I'm using both this comment and a sharp comment, probably markdown. And so this function is called, again, known by many names, but I will suggest we call it Flatmap. It's also called chain in some implementations, fmap, I believe, but I will call it Flatmap. And then if you have a box and a map and an AP and a Flatmap, you have a monad. So that's a monad. That is simpler. There you go. Voila. We just managed to implement in roughly 15 minutes. We just managed to implement a monad and introduce a lot of bizarrely named concepts. So let me. We have still 15 minutes left. There's a second part of this exercise, but I sort of want you to get the most out of it. So let's do a bit of a Q&A now. Yeah, what other questions, comments you might have, or is there something you want to share? Is there something you want me to explore a little bit more? Can we get a real life example of when you'd use one? I knew this was coming. Yeah, this is actually a very good question. Now you need to be very patient with me here because monads are easy to introduce, and it's sort of like. So I'm gonna do a bit of a preamble to excuse myself. It's sort of like learning a new language. You learn a few words, but then to make a full sentence. It takes a little longer. So I'm going to ask you to be patient with me. I try to make as simple as possible example, and you tell me if I succeeded. So a simple example. So a simple example I had. A simplest way to use monads, and you might already be familiar with this. The one example of monad is it's called an option or a maybe. And actually, if we have enough time, that was the second part of an exercise, we would actually implement that. So it's not difficult. It's really easy to implement. So we would implement that type option. Option is a design pattern that deals with a situation where something in the system might exist or not. So now I'm sure all of you have struggled with undefined is not a function and something being undefined and something being null, and then you try to add two nulls together, or you try to add null to a number, and it's just, you know, nightmare. So nulls and undefineds are nightmare. They're awful. And every single programmer eventually learns to hate them. There was one famous guy, I think it was Dijkstra, or maybe Hoare, who said there was $1 billion mistake to introduce nulls and undefineds. And optional monad, maybe monad, actually allows you to deal with this problem, make this problem go away. So I'm going to try to show you. Can you post the link again? Which link? Sorry, Katrin. Yeah, let me. I'll just send a to the monad. Yeah. Okay. Oh, sorry. That's not the one. Sorry, monad. Sorry, just responding to chat. But the second one is correct. So an example here, which might not make sense initially. So you might need to kind of, you know, maybe after the presentation, dig into this a bit more. Is in procedural programming, what you see on the screen, the code example, in procedural programming, in the standard code, you would say, okay, if something is undefined, do this, but if it's not undefined, do something else. And later on, okay, again, it might be undefined, so I have to check if it's not undefined. If it is, I'll do something else. So, you know, if X is undefined, send to database, but if it's not, console error. If, again, later in the code, if X is undefined, send to, sorry, it's not undefined. It's actually wrong. I just noticed. Send to external service. So you can see this should be reversed. This should check. So my point is proven. This is how annoying undefineds are. It should actually be reversed. It should check whether it's not undefined. So if X is not undefined, send it to external service. Otherwise, throw an error. Now, if you use monads, you could use this magic function called fold. And you're already familiar with map. So map will always return a monad. So it'll return a and that monad then you send function to the monad. So you've seen this in our examples. We send functions to monads rather than operating on them directly. And you would do the same with option type. I hope that makes some sense. I understand that because I'm kind of jumping ahead of the class because we haven't had the second exercise. This might be a little tricky. But the idea is that with monads, you give them functions, and then they apply, they're the boxes, they apply the functions inside, and then instead of putting things from, taking things from boxes. So it will never break. So trust me, this will never break. You don't have to check whether something is undefined or not. This will never break. I hope that's remotely helpful. And hopefully, if we have a little more time at the end, we'll do at least the first part of the exercise, and then you'll notice how that will close the loop. Is there any more questions in the Q&A or comments or things you want to share? Yeah. So so again, Darren tends to again, Darren wins in terms of explaining things. Yeah. So fold somehow knows to call the right functions depending of whether there is a value in the box or there's no value in the box. Thank you, Darren. You're amazing at explaining this these things. It's surprising. I'm here having this workshop at the moment. Cool. Since there's no more questions, let's just do it very quickly. The last bit of the exercise, and that will give you little more hints on this what I just said about practical use case, because I think that's the essence of what we want to get here. We want to see how monads are useful in a practical sense. So really quickly, let's get back to our monad. Okay, so now we had a box here. As some of you may have seen that I drew this wonderful, amazing box here. Now, we might, let me stay with me and something that I will try here. So now I will rename our box function. I will call it sum. And then I will rename these parameters and I will call this optional, or option actually. So this will be called option. This will be called sum, called option again, function with option. Sorry, a lot of boring refactoring. Again, new option. Basically renaming things, right? Like exercise of instead of a box, we're going to call it option. If we call something different, it's so much better, isn't it? We call this sum again. Oof! Wow, that's weird. That never happens. Passes on the first go. So now we have an option instead of a box. So I'm just fixing this drawing because it's important to have the right drawing, right? All architects know that. So we have a sum function, and now we'll have a second function. We'll call it none. And we'll do a bit of trick here. So again, trust me that I know where I'm going. We'll add another key. We'll call it the tag, and we'll have a tag called sum for the sum function, and for none, we'll just return the tag called none. Okay, so everything is still working here. And now we'll add a step 1a for our functor. And what we'll do is we'll say this. If I'm giving nothing, every kid knows that if you are given nothing, you get nothing back. So we'll extend our function. We need to extend the functionality of our function so that if it's given something, it returns something incremented. But if it's given nothing, it just gives us nothing. You get nothing, you give nothing. Okay, so I'll share this link with you, and I will give you 2 minutes since we're sort of running out of time, 2 minutes. So it's really fast to have a go at it. So you need to re-implement function map. You need to extend function map to support this new use case, this new feature. You have 1 more minute. Okay, so am I running overtime, by the way? Did I get it wrong? Should I have finished 8 minutes ago? I'm now slightly confused. Uh-oh. Yes, I think I ran over time. Matt Warnock. I think Matt would be starting. Yeah, sorry, Matt. Let me just show the. I thought it was 35. Let's just let me just show you this example, and I'll finish with that. So I don't leave people hanging. Okay, so very quickly. Now what we'll do is we'll apply this magic pattern and that's why I added the tag. So you'll see what I did with the tag there. I will use a switch statement. I know a lot of you learned switch statements are evil, but they're okay here. Trust me, they're fine. They actually borrow from a functional language pattern. So if if the tag is sum, so if we have something in the box, we just return something. But if we have nothing in the box, I mean, you know what we do? We just return nothing, because if you get nothing, you give nothing. It's the dog-eat-dog world. And the test passes. And that's what Darren explained so well. I'm just looking at the chat. So these functions somehow know to call the right function depending on whether there's a value in the box. And I'll just send you a link with your homework, so you could actually extend these other functions for handling when there's nothing in the box, and then you will have a monad for your optional type, which basically is very smart and knows whether do or not do something. So there you go, just sending the chat. So this is your magical homework, and I'm sorry for overrunning. I'm sorry, Matt, and I hope this was somewhat useful and at least demystified the functional programming and monads a little for you. And if it hasn't explained everything, at least it led you on the right path for you to to get there. Thanks so much.